Good morning, Etienne. How are you doing? Okay, let me bring a stream so that we can record the today's meeting, so that the other people would be able to hear what we've been doing.
Yes, okay. Welcome. Are you there?
Yes, I'm here. I'm here.
Yeah, welcome.
Okay, can you jump on my screen? Hello? Can you hear me?
Hello.
Yes, okay, cool.
Yes, I hear you.
Yes, now we can start today with a practical workshop. I'm going to show you Python, then we discuss about Jupyter for data analysis, and we are going to unlock some insights from data using Python built-in tools that makes data processing much easier. Again, this is day 6 of the Artisan Forge 2026. Well, Python ecosystem has been the industry standard for data science. There are several reasons that make a Python an industry standard. Everyone needs to know Python, needs to use Python whenever he's dealing with data. It has a syntax which is much easier. It is easy to run and use due to its built-in packages. You don't need to invent many functions, many activities. They have been pre-built and inserted in Python for you. Well, why do we use Python for data? The first one is readability. Well, Python codes, it is like English. It allows you to focus on logic rather than how you'd be focusing on syntax. You can view this code in this image on the left, probably written in something that looks like PHP. It is somehow complex rather than the way it should be implemented it using Python. The second is the ecosystem of Python has very powerful libraries like Pandas to process CSV, Excel data, then NumPy to compute mathematics and other related mathematical formulas with ease. Then Matplotlib for visualization, making scatter diagrams, making histograms from the your data. The third one is the community. Python has a massive community support for troubleshooting and open source contribution. That is, whenever you are stuck doing a given task, you can join Python forums and ask and get help easily and faster compared to other programming languages. Well, the next we're going to look about is the Jupyter environment. The Jupyter environment, it provides interactive computing and rate-led programming. Well, in interactive programming, you learn code in discrete cells, seeing results immediately without running the entire script. That is, you can have like a single line of code, 2 to 3, run them, see what they produce, and it is efficient. It is efficient because you can learn a given section of code for testing or to understand what is going on. The next is rate programming. That is, it combines executable code with rich text, markdown, equations, visualization in one document. That is, within the notebook, you can add some markdowns that are guidelines or comments. Then we can add computation as well as visualization in one file, which is a notebook. Well, it's visual feedback. Jupyter Notebooks provide inline visualizations. This light loop between data processing and visual confirmation is vital for exploratory analysis. And we use Matplotlib inline logic command to render plots directly below the cells. That is, for every cell you execute, if it needs a visualization or you need to see how the data can be plotted, the data can be visualized, well, it provides immediate feedback. The essential libraries that we shall be working with today, on today's task is Pandas known as the Excel for Python. It handles tabular data via data frames. Data frame is made of a sequence of rows and columns that keep data in the intersection, which is a cell. NumPy is a foundational library for numerical computing and multidimensional arrays. Whenever you are making complex multiplications, either you are multiplying vectors, you are echelonning matrices, well, NumPy would look very handy rather than programming every code to multiply vectors. Well, NumPy will have a way to do it easier and with little lines of codes. Then the next is Matplotlib, which is a low-level library for creating static, animated, and interactive visualizations. We shall use this to draw some distributions, to draw scatter diagrams, histograms, and many more. Well, data correlation, okay? Our data set is made up of different columns, different fields, and we can plot to see some correlation. Right, as you see this graph showing names and weights. We are analyzing individual variations. Analyzing individual variations often requires bar charts. In Python, we map categorical data, names against numerical metrics, weights, okay? That is, our graph needs to show a category of data. When this is, okay, this is January, we have this is February, this is March, this is April, this is December, and we need to indicate, well, the color, so that understanding the distribution will be much easier. You can see, like, whenever the color is red, our target has been missed. Whenever the target is gray, well, the target is actual. Well, then this is a snippet that you can try out. df.plot, x equal to name, y equal to weight, kilogram, kind, bar chart, okay? Then The name is the name, either January, February, then weight in kilogram, that's the weight that we have in a data set, and the kind, you can specify either we want bar, a diagram, either we want a scatter diagram, something like that. Then, today we are going to calculate the BMI. BMI is a body mass index, is a metric that can allow you to know if people are underweight, they are in normal ranges, or they are obese, they are in risk of suffering from obesity. It is calculated by taking the weight in kilograms over the height in meters squared. Okay. And in data science, we often engineer features by combining low weight and height. We create a more descriptive indicator of health than weight alone. Okay. Features in data science are like columns that we use to combine to compute the output. Okay, that is, if we combined weight and height to predict the BMI, then BMI is the predicted value, while weight and height are features. Okay. Then the next session is going to be about hand-ons. Then it will be your time to explore the starter notebook, which will be added in the description section of this video being recorded. Okay, your mission is to load the CSV into a data frame, then calculate BMI and average weights, then plot distributions by gender. You will have to say like female are more obese, and you can say male are, yes, you can perform some computation. Okay. Then here we end with a quote from this man named Clive Hamby, who said, "Data is the new oil, and it's valuable if unrefined. It cannot really be used." Okay. But if unrefined, it cannot be really used. Okay. That is, I can also take this quote with another speech I listened from a white woman when he was saying, like, without information, you cannot talk, you cannot read. And information is obtained after processing data. Okay. Then, before we have some questions, Remy, I think I can show you the starter kit.
Sorry. Hello.
Hi.
I have a problem. I didn't access your screening, so I just only hearing the voice. I didn't see what you are doing.
Well, you can see that in this meeting, I started sharing my screen. You can tap on start watching. I think there should be a way.
Oh,
Okay. Yes. Okay. Then let me show you my starter kit. Discord. Okay. Okay, I'm in Discord. Let me change my stream to be this. Okay. Then blah blah blah. This needs to be. Is it this? Not this. Is it Discord? Not Discord. Okay. Okay, let me use the what? let me use Colab. Then with Colab, I can upload my notebook. Okay. Okay, I can upload the notebook. Let me see, it is here. Starter kit. Okay, I will have to show you another presentation. Yes, it should be this. Yes, it should be this. It should be that. Okay. Yes, cool. And I need to also upload my dataset. Cool. Well, and well, here is the starter kit. Let me see. Well, you can see my screen. Then you're going to load the data in this frame. Then, as you can see, Colab is made of Markdown. This is a Markdown, and this is the code. Okay, you can see. Let me try. If I load this code, well, maybe nothing will happen, but maybe something will happen. Your role is going to explore this. It has guidelines of what to do. Then, yes, you would have, of course, to do some research. I can recommend you to Google W3 scores, then open Pandas. Let us try with Pandas. Then let us see how to read the CSV files. You can see how simple. You need to import Pandas as PD, then PD read the CSV, you put the name of the file, then you print df.toStrings, which is much easier. Let us try this, okay? You can say like, oh, you can add some codes here by hitting code, okay? Then import PD as PD. Okay. Then after importing PD as PD, you can lead a data frame. Then let us see how you can read the data frame. I'm going to put it in same package, of course, but I will need to upload. Oh, okay, there are some CSV. Let me read California housing test CSV. Luckily, I found one. Okay, .csv. Then I'm going to print df this way. .head. It will show me what. Let me see. No such file. Well, it is not present here. You need to open sample data this way. Then slash. Well, you can see the head of this data set. It has longitude, latitude, housing median, total rooms, total bedrooms, population, households, median income, median house. Okay, you can also like refer to this, then print to string. Okay, that is the string. Well, I have to see it is a 2_ string. Well, it puts your df in a string, then present it. Okay. Thank you once again. I'm going to attach this notebook to the description of the program. After attaching the description of the program, you'll be able to complete it using a starter kit of notebook. Again, you need to Google how to read CSV. You need to study how to use NumPy